we take the floor function of x, it basically means to find the greatest integer less than or equal to x. So for example, if we take the floor function of 2.7, we get 2. And if we take the floor function of 1.8, we get 1. But we can't jump to conclusions and solve the integral just like that. We need to understand the graph of e to the x, right? So from bounds 1 to about infinity, we know that the graph slowly approaches 0. So there must be a range. There must be a range of e to the x for which its floor function will equal to 0, because the values of e to the x will be from 0 to 1, and there will also be values of e to the x which is from 1 to 2, and values for e to the x which are greater than 2. So now we can turn it into steps. So let's find when e to the x is greater than 2. We know that the range will be x is lesser than e to the 2, right? Now let's find when e to the x is between 1 and 2. For that, we know that the range will be e to the 2, and x is greater than e to the 2 and lesser than or equal to e, right? And now we know that for any value greater than e to the x, the range will be x greater than e. So now we can rewrite the integrand as e to the x equal to 2 when the range is 1, where x is greater than 1 or equal to 1, and lesser or equal to e to the 2, and floor function of e to the x is equal to 1 when x is greater than e to the 2, and lesser than or equal to e, and e to the x is obviously 0 when x is greater than e. That's because it starts to converge towards 0 as x approaches infinity. So now we can rewrite the integral. We can rewrite this integral 1 to infinity of the floor function of e to the x dx as multiple step functions. So from 1 to e over 2 is equal to 2 dx, right? The floor function of e to the x, e over x, is equal to 2 between these two bounds. And we can add up, and we know from e to 2 to e, the floor function of e over x is equal to 1 dx. And we add up from e to infinity, we know that the floor function of e over x is equal to 0 dx. Now we can solve these integrals